So when we deal with the multimedia database, actually, we can have the spatial relationships. What is the spatial relationship? For example, I want to know property P1 on top of property P2. So you can see, for example, the yellow is on top of blue. For example, if you look at the kind of image, the cloud room is on top of the mountain. So you can have that kind of spatial relationship. Or the picture one, next to the property of the picture two. So for example, the green color is on the left or on next to the blue color. So that kind of things, you can look at the detail resolution. Maybe if your resolution is 8 multiplied by 8, it is more detailed. But if your resolution is 2 multiplied by 2, maybe it is less on the resolution. Or if you have 1 multiplied by 1, it is only the summary. So you can do with the different multimedia database. So we call this is the cost to find resolution mining. Coarse means rough. Okay. So this one is the example of rough picture. Sometimes we cannot understand what is it? It's too rough. But if we go to fine, so this is the fine. So the fine is like more detailed. So we can see the detail that, okay, this picture contains of the lamp. Okay, we have lamp, we have book, and we have banana. We can also do with the cost to find from this picture. So if the resolution is very small, then we cannot see the detail. If the resolution is bigger, or because this is the fine resolution, then we can see the image. And also when we have the multimedia database, we will have some more challenges. For example, some pictures are blurred. Or for example, some of the texts are scratched, not properly attached. Or some of the pictures are have some noise. So this kind of picture, or like this one, the banana has been captured with other picture, so you cannot see what is the detail. So this kind of the multimedia database access, and you need to know how to handle this kind of data. So the challenges is the curse of dimensionality. You still remember? When we learn this one, we learn in the data reprocessing. The curse of dimensionality. Dimension means the number of attributes. If we have a lot of attributes, if we have a lot of columns, then it is more challenging because you need to handle very huge data. So if there are a lot of dimensions, so it is difficult to implement a data cube efficiently, given a large number of dimensions. Especially serious in the case of the multimedia data cubes. Many of these attributes are set oriented instead of single value. What does it mean? Set oriented. If you look at this first part of this slide, we have the set value attribute. So the set value attribute, it is referred to the set oriented. So it means the data usually is not single value like this one. The data might be the set. A set of sport, it means the tennis, hockey, and chess. A set of activity of cook ramen, then this is the detail or the single value. So sometimes if we have only the set value, it is also challenging when we deal with the multimedia data. Restricting number of dimension may lead to the modeling of an image at a rather rough. Okay. So we learn about rough, it is coarse. We cannot see the detail. We cannot see the exact picture. Sometimes it is also limited and imprecise scale. So we cannot restrict the number of dimensions. But if we have many dimensions, the computation will be so expensive. So more research is needed to strike a balance between efficiency and the power of representation. Okay. Okay, I think that's all about the complex data analysis. We learned about the multi-dimensional analysis and descriptive mining of complex data objects. So you will learn a little bit about the spatial database, and then you learn also about the multimedia database. Okay, I move to the next section, which is about the basic deep learning. I think this will be the last PowerPoint that I will use to explain the lectures in this data mining class. I'm not sure if you're going to use the deep learning in your team project or not. But in the class A, some of them, they want to apply the deep learning. And I think it is good for you to understand the basic concept. So in this lecture, I will just explain the basic deep learning. So I will just introduce what is deep learning and the basic concept about the network. And then what is the performance measures that usually use in the deep learning. And at the end of this slide, we will learn about some trend of the data mining. Okay, what is deep learning? The word deep learning means we use a neural network. So you already know the neural network. You already also look at the quiz. Okay? In the quiz, we learn the very basic neural network. And the deep learning means the neural network with several layers of nodes between input and output. Several layers. So the layers is not only one, but it can be two, it can be three, it can be four, and so on. The series of layers between input and output do feature identification and processing in a series of stages. just as our brains seem to. So if we look something, okay, if okay, I want to see the dot over there, then yeah, our brain will have some kind of processing. Okay, that is a door, it contains of a window, and then it contains of a doorknob, and the color is brown, and etc. So there's a kind of series of stages to indicate that it is a door. So there are good algorithms for learning the weight in networks with one hidden layer. What does it mean, one hidden layer? We have only one in the middle. So this is the input. This is the input of the neural network, and this is the output of the neural network. And we have only one hidden layer. So many good algorithms we can use when we have only one. However, these algorithms are not good at learning the weights for network with more hidden layers. So if we have many hidden layers like this one, 2, 3, 4, we have 4 hidden layers. So the algorithms here is not good to find the proper weights. Okay. So when we have the multi-layer neural network, we will calculate or we will do the train for every of the layer. So we need to train this layer first from the input into the first layer, and then we train the next first and the second layer, and then we train the second and the third layer, and then we train the third and the fourth layer, and finally we will train the last layer and predict the output. So that's usually we can do with the multi-layer neural network. And whenever we do the training, okay, each of the non-output layers, so this is the non-output layers, because this is the output layer, this is the non-output layers, it is trained to be an autoencoder. So if we finish this one, so it will be trained as an autoencoder, and basically it is forced to learn good features that describe what comes from the previous layer. So when we have this node, it will make an autoencoder to make some value which is good for this one, and then we will train again to be an autoencoder, and then it will produce some values for a better representation for the next node. Again, we will train as an autoencoder, and then it will produce a number that is good for the next node, and so on, until we know that this can predict the output. So these intermediate layers, okay, we call it the intermediate layers. The intermediate layer is the layer between input and output, are each trained to be autoencoders or simulators. So we need to check what is the proper value to give the input to this layer. What is the best value to give the input to this layer? So every of this layer will be trained. And the final layer trained to predict class based on outputs from the previous layer. So the last layer, this one, it will be trained, and the result from this node, it will be used for the output layer. So the idea of deep learning, actually, it is similar with the machine learning. You know about the classification, you know about regression. So all the things are learning the data. So we also use the deep learning to learn the data. It is like machine learning, but it is more about the neural networks. So last time you learned about the neural network. So that's the very basic one. We usually call it as the artificial neural network or the ANN. So this neural network, actually, we can have different architectures. Deep neural network, or we call it multilayer perceptron, convolutional neural networks, recurrent neural networks. Some deep learning libraries, for example, the TensorFlow, yeah, we can use it. It is written by Google. Keras, the TensorFlow, Microsoft Cognitive Toolkit, and PyTorch, it is written by Facebook. So if you use Python, I guess you can use these libraries. So the idea of this deep neural network, or sometimes they call it also multi-layer perceptron. So we have the multiple layers. What does it mean, multiple layers? The layers between input and output, it is more than one, greater than one. But sometimes people say that maybe it can be greater than two, or sometimes people say it's greater than three. Yeah. Anyway, as long as it is higher than one, yeah, we can call it as the multi-layer perceptron or deep neural network. Since the number of multi-layers are undecidable in many works, so there is no such template. For example, I want to use 4 layers. 1, 2, 3, 4. Okay, that's okay. But sometimes you want to say, I do not want to use 4. I want to use 3. Okay, that's also fine. Professor, I want to use 10 layers. That's also fine. But of course, when you have many layers, the computation time will be higher. Even though the result might be very good, but the computational time will be very expensive. So whenever we have the many layers, yeah, we will call it as the deep neural networks. So the development of the neural network trigger the generation of other neural networks such as CNN, or we call it convolutional neural network, and recurrent neural network, or RNN. So CNN, what is CNN? We call it the convolutional neural network, or CNN. It is the foundation of most computer vision technologies. The computer vision means we want to use the computer to see what is this image. So maybe we can see that this is an image of a bear reading a book. A doll bear reading a book. So the computer can try to understand this image. So what is the building block of the CNN? Whenever we have the CNN architecture, there will be convolutional layer, there will be pooling layer, there will be fully connected layer, and there will be activation layer. Okay, let's discuss one by one. Convolutional layer. What is convolutional layer? The convolutional layer use filters that perform convolution operations as it is scanning the input I, sorry, I have two letters, I with respect to its dimension, and its hyperparameters include the filter F and the stride S. The resulting output O is called the feature map or activation map. Okay, maybe it is difficult for you to understand. So if you still remember when we use the pre-width, you still remember the pre-width kernel? Okay. So when we use this pre-width kernel, this is the pre-width kernel or the pre-width operators. Sometimes we call this is the pre-width kernel. So when we use this pre-width kernel, the example here, we use 3 multiplied by 3. The input is 5 multiplied by 5. Okay. So for every 3 multiplied by 3, we will check the component 3 multiplied by 3. And then we will get a value, and the value will be placed here. So the idea is the same with the convolution. So this is the idea of the convolution. So we will make the data that we have, for example, this one, 6 multiplied by 6. So I would like to do the convolution. So I would like to filter, sometimes called as kernel. So the kernel that we learned, it was the pre-width. It's passed over the image and viewing a few pixels at a time. So for example, I saw the 3 multiplied by 3. So I will see the 3 multiplied by 3. And then I will see another 3 multiplied by 3. And then I will see the next 3 multiplied by 3. We can also define, for example, 5 multiplied by 5. Then it means I will have like this one, 5 multiplied by 5. So I will check this one and then do like the pre-width kernel. But in the pre-width kernel, it is 3 multiplied by 3. Whenever we have this 3 multiplied by 3, okay, we call this is the filter with the pre-width kernel, for example, and we have the stride S. What is S? Stride. Stride. If we have the stride equals to 1, then we will move this 1 step. We will move again 1 step. We will move again 1 step, like this one. But if we have the stride equals to 2, whatever, the first we will start from here, and then it will shift 2 cells if it is the stride equals to 2. If we have the stride equals to 3, then from the first we will change to the next shift after 3 cells. The convolution operation is a dot product of the original pixel values with the weights defined in the filter. So if you look at the pre-width, okay, the pre-width, the gx and the gy. So if it is the gx, so you will make dot product with the x. The right one is using 1, 1, 1. The left one using -1, -1, -1. If it is y, the bottom one, you use 1, 1, and the upper part we use -1, -1, and -1. Okay. So that's the very basic weight in the kernel based on the preview. The results are summed up into a number that represent all the pixels as the filter observed. So after we have this one, we use, for example, the preview gx and gy. So we will get a number, and the number will be sum up, and the result will be placed in this new matrix. So that's the idea of the convolutional layer. The pooling layer. So the pooling layer, we call it, this is a downsampling operation. So if we have a lot of data, we want to reduce the data. So we can just do the downsampling. It is typically applied after a convolutional layer, which does some spatial invariance. So a filter is passed over the result of the previous layer. Select one number out of each group of the values, typically the maximum, and we call it, this is the max pooling. Max pooling. This allows the network to train much faster, focusing on the most important information in its feature of the image. So in particular, max and the average pooling are special kind of pooling where the maximum and the average value is taken respectively. So for example, let me use this number. Okay. So I want to have the 3 multiplied by 3 like this. 3 multiplied by 3. And then I want to apply the max pooling. What is the result? Max pooling, it means I will check the maximum value from this pool or from these values. What is the maximum? We have 5. So we will use 5 from this one to generate a new matrix. And then we will do the next. Okay. What is the maximum? 2, 4, 5, 2, 5, 6, 4, 2, 7. Then we will get 7 as the maximum. And we will go to the next. 4, 5, 2, 5, 6, 2, 2, 7, 1. What is the maximum? 7. So we put 7. And so on until all we finish from the input. This is the max pooling. What is the average pooling? The average pooling means we will take the average value from the pool. It means we will do the 1 plus 2 plus 4 plus 5 plus 2 plus 5 plus 5 plus 4 plus 2. And we will do the division by 9. We can get the average value, and this average value will be placed into the new matrix. So this value will be put into the new matrix. So the second one, which is 2, 4, 5, 2, 5, 6, 4, 2, 7. We will also again calculate with the average, and we will put it into the new cell of that matrix, and so on. Okay. So that's what we call as the pooling layer. we have the maximum pooling and the average pooling. Fully connected layer. In the fully connected layer, we have the operation to flatten the input, where each input is connected to all the neurons. So for example, here we have a matrix. So sometimes we call it the matrix is based on the node. Okay. Let's say we have 1, 2, 5, 2, 3, 6. For example, 4, 3, 2. Okay, like this one. 3 multiplied by 3. So when we do the flatten, it means we will make into the factor like this one. So the factor will be 1, 2, 5, 2, 3, 6, 4, 3, 2. So it is in the one row. Oh, sorry, in the one column. After we generate this one, then we will make the common multi-layer perceptron structure. So the one that we create this one, it will be the input for the multi-layer perceptron, and the input is one-dimensional vector. So this is the one-dimensional vector representing the output of the previous layer. So it is the output from the pooling layer, and its output is a probability for different possible label attached to the image. So for example, if I have the image, the result, I know that there are 3 pictures: dog, cat, and bird. So what you will get from this neural network is the probability. For example, I know that the probability is 0.7 for dog, 0.2 for cat, and 0.1 for bird. Then the highest probability is 0.7 will be selected. So the label that receives the highest probability is the classification decision. So there are some problems later that we will learn about the activation function. You still remember activation function? In your quiz, you have one activation function. What is the activation function? It is the sigmoid function or logistic function. Okay. So why we need to have this sigmoid function or the logistic function, or any activation function? As more layers using certain activation function are added to the neural networks, the gradient of the loss function approaches 0, making the network hard to train. So if you have many layers, and when the layers calculate the values, there is a possibility that it will create 0. That will create 0. So 0 multiplied by 0, it will be 0. So if everything is 0, then of course the network will not work. Because this is the vanishing gradient problem. It limits the development of the deep neural network with classically popular activation function, such as the hyperbolic tangent. So if we use the hyperbolic tangent, if the potential 0 occurs, then the network will be always giving you 0, and that is not good. So How to fix this new neural network or the multi-layer perceptron for the classification? We can use ReLU or some other with initialization. So the activation layer, okay. The activation layer means the convolutional layer that generates a metric that is much smaller in size than the original image. And this metric is run through an activation layer, which introduces non-linearity to allow the network to train itself via back propagation. So we learned about the back propagation before. Okay. So this back propagation, usually it requires the activation layer. Okay. The necessity of using the activation layer. Okay, I think this is the same. Yeah, I think this is the same with this one. Let me skip this. So several types of activation function is like this one. We have the sigmoid. You already learned the sigmoid. Tan, hyperbolic tangent, ReLU, rectifier linear unit, and some other variants of ReLU. So this is the activation function. The sigmoid function or logistic function, this is the formula. You just know the formula, but now I would like to explain that the range of value will be from 0 until 1. So the value, yeah, it will give you a kind of value which is not always 0, but it will give you some values with a better approach for the next layer. We call it, this is monotonic because it's monotone like this, differentiable, and the derivative is not monotonic. If you use the hyperbolic tangent, that's a range between -1 until 1. It is monotonic and differentiable, and the derivative is not monotonic. The new activation function, people tend to use this activation function. We call it ReLU, rectifier linear unit. So the range of the value is between 0 until infinity. So it means whenever you reach in the formal value, it will not be 0, but it will give you some big values. So the monotonic is monotonic. It is differentiable when everywhere except where 0, and it is monotonic for the derivative. So at the end, yeah, this is the complete architecture of the CNN. If you have a zebra, for example, so we will check the kernel. What is the kernel? Let's say I use the private. Yes. There are many other kernel. So I can use the convolution and the ReLU. For example, this is the activation function. And then I will do the pooling. And then for the next layer, I will again do the convolution and ReLU. And then I do the pooling. And then for the next layer, I will do the convolution plus ReLU. And then I will do the pooling. And let's say this is the last layer, I would like to flatten. Flatten means I will make into one dimension factor. And then I will do the multi-layer perceptron. After I have the multi-layer perceptron, then the output will be based on the label that we have. For example, horse, or zebra, or dog. And the highest probability is the label, or this is the prediction result. So we do not need to extract the feature one by one, but let the network determine the features. We call this is the feature extraction. And then we will do the classification. And last, we will check the probabilistic. Okay. I will stop here. Okay. So, any questions?